Hello, everyone. This is Matthew Taylor, and this is a recording of the Data Quality 101 training session from the Data People Summit in Boston. So without further ado, let's begin. A quick introduction to me before we start. My name is Matthew Taylor. I am Projects and Solutions Director for Ataccama in the UK, in London. We have a team of consultants here which provide anything from training all the way through to project implementations. And we roll up to a global team with other consultants in Toronto, in Prague, in Australia, and then a few dotted in other offices around the world. I've been in Ataccama for 3.5 years now. Prior to that, I was a product manager of a data management product. And then prior to that, I spent 15 to 20 years in the investment banking world, doing all sorts of data things, including customer CRMs and MDM products and various other things. In the session, we will talk about the people in the session. So let's talk about the audience for this session. It's a 101, it's an introductory training, assuming absolutely no knowledge whatsoever. And really the goal of this is just to provide some initial understanding of terminology, the types of processes you'd have in a data management space, and the sorts of things you might want to consider when you're starting a new project. Is a definition of data quality management. This is in two parts here. So the first half of this, talking about what we call stewardship, and many different terms for the same thing. But think about data stewardship is talking about the things we do, processes, policies, procedures, people, training around an enterprise to make sure that your data is trustworthy. So that's the first half. The second half is more functional. So how do you do it? It involves profiling, matching, merging, correcting. So taking bad data and doing things to that bad data to make it good. And obviously using tools such as Ataccama is a subset of that. Here's my quick agenda here. We'll first talk about why we want to do this. This may seem obvious, but we can talk about the things that you might think about when trying to make a case for doing a DQ project. How might you think about return on investment? And often this comes down to things you don't notice, such as risks that you're carrying, which could have a certain weight. We've got some case studies which will help us with that. Then we'll talk about what a DQ project is. As a spoiler alert, it's not just a tool, it's other things as well as the product. You can't just purchase Ataccama and see your data problems magically go away. You need to create some structure around it. And then once you've got your project in place, how are you going to do it? And then finally, if there's time, when do we do it? Well, as soon as possible. And who does it? Do you centralize everything into a core team, or do you distribute work out in a sort of more democratized fashion so that people can help themselves, or some sort of hybrid between the two? So that's the agenda. Let's get cracking. First, why? Why would we want to start a DQ program? Here's some real world examples, anonymized examples, and you probably have your own examples which are in your head, which follow similar lines. First one, the home of James Bond, MI5, here in London, confessed that they bugged 134 incorrect phones. I personally would imagine it's a lot more than that, but that's probably the ones they got caught for. But the key thing in blue here, misunderstanding the format of phone numbers. So you can translate that to many other things. Understanding your data is the problem here. Number two, global investment manager, they had an error which caused an overestimate of some clients' losses. although you are going to have data problems, the issue here was that they then didn't declare this mistake and they covered it up. So it was the cover up which led to this giant fine, 242 million US dollars, for the cover up, not the data issue. So here we're thinking, there's something beyond just the data here. Maybe it's the processes. Next one, a missing minus sign. Somebody had caused a dividend, a large distribution of cash to investors, 1.6 billion pounds in the UK, had to be cancelled and reversed. Seemingly the reversal happened and that was okay, but the problem here was reputational risk, reputational damage. Very difficult to put a number on the value of reputational damage, but there it is, right? So when we think about data problems, we need to try and quantify the risks that we're carrying by not resolving them. And then you have this man at the bottom here. I know his name is Liam, and back in 2020, when the COVID vaccine first came out, here in the UK, we were giving that vaccine just to people who were elderly, over 70, and people whose body mass index, which is their height divided by weight, was high. So I think over 40. Anyway, Liam's body mass index in the NHS systems was 28,000. Why? Because he was in the system at 6.2 centimeters high, not 6'2". So I don't know what to say about that data error, apart from just make sure that you're validating your data and making sure that it's realistic. We'll come back to him later on. So what did we see in those examples? There's a few things bubbling up there. It's not just the data, it's how you deal with the data. It's not just having problems with data, it's how you proactively solve those problems. So first part of here, so why implement data quality management? This is kind of part of your business case here. Mainly risk reduction. If you know how to make a risk log, you can write down a bunch of what ifs. What if this happens? What if that happens? And against each of these what ifs, you could try to quantify the financial impact of that risk actually becoming an issue and actually occurring. And then you can try and provide probability of that happening. And then you can risk weight, which is to multiply the impact by the percentage probability. And that will give you value of the risk that you're holding by not resolving certain issues. We can see here regulatory risk, fines from regulators, reputational risk. Very difficult to quantify what the lost business would cause you if you had an issue like our distribution on the previous page. Security, data risk, and then just your general operational risks, which will probably be easier to quantify. What does it cost you every time some piece of manufacturing product is incorrect? And how can you improve that? And how can you measure it? So everything comes down to risk ultimately, and quantifying risk. But it also comes down to emotions. And for those that watched the CEO keynote speech as part of the Data People Summit, you'll see that Michael Klaus had a slide on the screen with one word, and that said frustration. And this is the thing. So there's frustration, there's confidence, and I put time here as well. If you are a fully qualified accountant or economist or engineer, and you're spending 80% of your time fixing data problems or spreadsheet issues, and not much of your time doing the thing you qualified for, that's going to be very frustrating. So trying to sort data issues out proactively gives you your time back, and you can get on and do your actual job. I put confidence as well because there's an issue here about people's confidence in your data, your own confidence in your data, and improving confidence will help you sleep well at night. So those are the types of things that you can think if you're making a business case to do a DQM program or project. Some numbers. The key takeaway from these numbers is that they're all fairly small. This is from a thing we do every year called the Ataccama State of Data Quality Survey, this year's survey. And you can see only 16% of the respondents, and there were 1,000 executives that responded to this survey. It's a third-party survey we do. Only 16% say they have high data quality management maturity, which is very low. Only 31% are actively managing master data and reference data. Only 26% are managing metadata, which is the data that describes the data in your organization. And slightly higher, 41% of organizations have some sort of data governance in place, but it's still fairly low. So if you're listening to this and you're new to the data quality management space, and you feel that you're behind the curve, you probably aren't. Seemingly the entire industry is behind the curve, and maturity in general is in its infancy. We're still finding terminology to use for certain things that we've been doing for years. So don't be disheartened if you're early in your journey, is the message from this slide. Okay, that's the why. Now what? So here's a true story. It's about a supermarket chain and their launch of a new store. So what happened in this case, and it is a true story, is there was a new store to be opened in the north of England, and everyone was lined up, from the celebrity to cut the ribbon and the newspapers with their cameras to come and open this store. But at the point of doing the opening, the manager realized the store was empty. Now, I guess people didn't think that it was meant to be filled with product, but you would like to see some nice glistening strawberries and fruit and veg filling your shelves when you open the store. But in this case, the delivery hadn't arrived. So behind the scenes here, what was going on? The real true root cause, technically, was that the list of all the stores was held in a spreadsheet, and somebody had forgotten to put the row in the spreadsheet to say this is the new store. As a result, the order of the products didn't end up anywhere because the store didn't exist. And it was only found out at the very, very last minute. So the true root cause is missing reference data and not handled reference data. But is that just the root cause? It begs this question: were there any DQ processes in place here? If you think about it, you might think not, but I disagree. There was. There's always a DQ process in place, and often that's when you find the bad data and have to react to it. So it's not really a formal, organized process, but here we introduce our first data quality rule. Here's the rule: there should be more than 0 items in a grocery store on the day it opens. And then the frequency of the rule is once, ad hoc, on walking into the store on opening day. Now, that's the rule, it's there, but is it sufficient? Well, clearly not. So as lovers of quadrants here in Ataccama, I've made a quadrant, and I've placed this one in the bottom left. So on the x-axis here, I have proactive to reactive, and on the y-axis, I have automated data quality and manual. So this is clearly manual. There was a check, but it was too late, and it was clearly reactive and it was not proactive. So we can start to think of ways to stop this happening again. And that means moving towards the proactive and sometimes moving towards the automated. But I say somewhat here. You want to go somewhat more proactive and somewhat more automated, but you don't have to, because there are in these other three boxes of the quadrant, there are valid cases where you wouldn't necessarily have automated proactive DQ all the time. Let's have a look. So let's start with the top right. This is where you've got some specific data. You know what that data is. You are going to monitor it and control it on a regular basis in an automated manner. And that's where tools like Ataccama can come in handy to lock down what your data is going to be. What are my critical data elements that I want to check on a regular basis and provide reporting and create mini projects to improve my data quality over time. But here's some other cases where you might end up in other quadrants on this quadrant. In the bottom right, I've got manual but proactive activities. So in here, I put data discovery or migrations. These are things that you would do as a one-off exercise. Again, maybe using a tool, maybe using SQL or some other approach. Let's say, for example, you take on a job as an application owner of 100 applications for a large bank. You've landed in this department, but you don't know anything about the databases and the systems that you've just inherited. So as a one-off activity, you can do a data discovery, and that is to look at all your data and work out what you've got and document it. That's not something you necessarily do over and over and over again, but you do it as a one-off. Or below this, migrations. Let's just say you're trying to eliminate 2 CRMs and create a brand new CRM. You've got a one-off activity here, which is to join the old data together, create a common single source of that data, and do a data conversion process and load it into your new tool, and then turn off the old tools, usually, hopefully. So there's a one-off exercise again. So those are proactive but manual jobs, which you can use tools for, clearly. Up in the top left corner here, I've got DQ firewall. So what is that? That's when you create logic to define your valid data, and you try and react to data going into the system at the point of entry. So you've all seen this in a web form. If you're entering a zip code or some sort of address or phone number, or credit card, that you get the validation message instantly as you're typing. It's reactive because it's reacting to data instantaneously, but it's also automated. So that's an example of reactive but automated data quality. The area you want to avoid clearly is bottom left. You will still have cases of manual reactive DQ, but that's where your risk lives. So if you can identify what risks are down in that bottom corner, then that's a really good starting point. Okay, so traditionally, this is the technical answer. Here I have just a sort of standard flow. You've got a user consuming information from some system that's loaded it from a bunch of places, and then making decisions on what they see. We have bad data going in at one end, and therefore bad decisions coming out at the other end. That's a very simplistic traditional answer of how you understand DQ problems, is you blame the data. But of course, data can go wrong at any point in this thread here on each of those arrows. And also, it might not be just about the data, as we've seen before. So to go back to our empty shop example, these aren't all technical problems here. There are two. I mean, this is a sort of simplistic list of the deep dive we did before. You've got reference data not being managed, relying on a single person, no history, Excel reliance, etc. But you've also got a lot of process problems here, and also a people problem. There was no defined owner for the data. There was no one whose role it was to make sure that this was correct. And so when we think it through, we end up with something like this. And you'll see this diagram in many formats from many different institutions with different names in the blobs. But essentially, it breaks down to these three things: a people dimension, a processes dimension, and a tools dimension. I've put some examples here of the types of things that happen across each of these dimensions. And really the key takeaway for this slide here is that it's not just about the tool. And clearly we in Ataccama, we love our tool and we want to promote it as much as we can, but there's things around the tool that need to be put in place. And that is everything from upskilling people to applying ownership, finding people with subject matter expertise, knowledge of your data in the people domain, and assigning them ownership appropriately, and then to the processes domain, so that you create a process which allows you to continuously improve your data over time. So we'll drill down into these three in the coming slides. So that's the what. Now, how? So these are the three things: processes, I say ownership for people, and then DQ tools and business functions. Firstly, let's have a look at a very simplistic process improvement work stream. Again, this wheel diagram, and we love a wheel diagram in Ataccama as much as we love a quadrant. Again, you see this in many different flavors through EDC or Dharma or various other places. People have their own preference on how they do a business process re-engineering or improvement plan, but they'll roughly end up the same thing. The first thing you do is define what you're going to do. Often that's driven by a risk assessment that you've already done, or you know some problem, you've had a data breach, you've got a regulatory need, so that the input into the definition will come from one of these areas. But this is your business requirements gathering. And then the next two, assess and analyze, they kind of go hand in hand, really. Essentially, what you're trying to do is assess your data quality and your data process maturity as an as-at state. You want to quantify it and have a snapshot of, here's where we are today. From that snapshot, you can then think, what are our highest priorities from this analysis, and how are we going to attack those? So then you've got an improvement piece here, which is to pull out of your assessment your top priorities, and then create a project being a fixed scope, fixed time, piece of work which attacks a certain requirement. You implement that project, improve a bit, put some controls in place to make sure that things are operational at the end of the project, and then you reassess and you keep spinning around this wheel. Theoretically, you improve. As every time you go around the wheel, you'll see a new version of your maturity assessment, and you should see all the numbers improving for you. So that's roughly how this works. And of course, the assessment is partially data quality assessment, looking at your data, and it's partially a process and people assessment. This is a data quality maturity assessment example. It's come from Google. Literally type in data quality maturity assessment into Google, and you will see hundreds of different versions of these in all different flavors, but they're all the same. What you see going down the rows here is usually different depending on your need. This is a fairly typical one. You can see people, process, technologies. They've measured the actual data itself, how well the business is aligned, risk, etc. And then you see an assessment. This one's got a 5-point scale from amazing on the right-hand side all the way down to nothing at all on the left-hand side. So this gives you a really, really simple visual view of everything from your data quality as at now, all the way through to your processes and your people and various other elements that you might want to look at. that's all we'll talk about for the business process side of things. But there are many, many more courses, and we can provide more information if it would help about how you run one of these improvement work streams. Now, we'll talk a little bit more about the tools. This is Ataccama's world. And what are you doing in a tool? What do you actually do in Ataccama? So again, another wheel here. And this is around the assessment and proactive monitoring and control of in this case, data quality. So let's spin around this wheel from the tool perspective. At the top, we have discovery. So remember the word discovery from the quadrant earlier on as manual but proactive activity. And how do you do discovery? Well, you do profiling. And what is profiling? Profiling is when you look at your data source and you generate a statistical analysis of your data. And then you create what we call metadata. And that is a view on top of your data. It's basically a database that describes all your data assets that you have in your organization. And it tells you everything about those data assets. So an asset, let's just say, is a table in a database. And you'll see within that table all the attributes it has, what data types they are, and we can tag things against this metadata, such as, is it PII information? Is it certain business terms? Do we recognize data to be similar to data elsewhere? And so on and so forth. And we can also tag things such as ownership, governance type of things, tasks, notes. So you end up with, let's just call it a Wikipedia on your data. And then once you've got this wonderful Wikipedia of your data, your metadata, or your catalog, as we call it, you can then search that when you need to find out where your data lives within your organization. So creating the profile, creating the catalog is a really key aspect here. Next, you will have determined certain types of data in your organization, and you start to get, just from the profile itself, you'll get insights into the quality of the data. You'll see where it's empty, weird formats, so on and so forth. That's great, and you can actually do a lot of data quality work in a manual manner using this tooling. But what you then need to do is think about, let's move up into the more proactive, automated, strategic data quality rules, and we can start to define what is valid data, and that's what a data quality rule is. In a simplistic format, that might just define the structure of something. In more complex worlds, you'll see that data can be valid depending on its context, and we will come on to that a bit later on. So once you've defined what your data quality rules are, you can then apply those rules to specific bits of your data across your organization, and then we go into the proactive monitoring of data quality. So there you take a tool such as Ataccama, create a monitoring project, which will say, I want to run these X number of rules against these Y number of source systems. That project can be run on an ad hoc basis or in a scheduled manner, and then your results go somewhere. So where do they go? They go to reports, but they also need to be remediated. And we talk about various methods of remediating data problems in a further slide. Finally, reporting. So this is data quality assessment, data quality reporting and monitoring. You should be seeing trends over time of your data quality improving. And then again, spin around this wheel and keep going, keep improving. So some screenshots here. We tried to keep this session tool agnostic as much as possible, but here's a screenshot from Ataccama to illustrate data discovery. This is a profile of some sample credit card numbers, And instantly when I see it, what's happened here? I've got glossary terms, so business terms is being tagged as a credit card number. So that's now searchable. We know it's a string. We know there's 140,000 of them. And we've got DQ insights here. So there are some significant number of empty values. You see null here is 60% of your data. So you may start to wonder, is this data particularly good or not? And of course, the answer is contextual. If I don't care about credit cards, why even store it? But if it's a billing system and I need a credit card against each person or customer, then this is going to set off alarm bells in my head. So valid or not is context specific. And then you can see some what we call masks. We can see what the data looks like. It's mainly all digits, thankfully, and so on and so forth. So you're starting to get a really good idea of what your data looks like, and that's the discovery process. One of the things we do, we often will do, where we see glossary terms here, that's your business terms. An organization might do an assessment of what we call the critical data elements, or CDEs is the term you might hear. And that is that we come up with a list of all the possible types of business data that we're using across an organization, and there'll be a lot of it. But amongst that, you usually have a key, say 30 to 50 or 100, what we call CDEs. And those are things that across your entire organization, you want to make sure absolutely top quality. And that's usually things such as, my customer data has to be correct, addresses, phone numbers, contact details, certain financial things like charts of accounts, and so on and so forth. These are the things that if you didn't get this data correct, it would cause the organization the most problems. So determine your CDEs. That's a very, very important part of discovery. Right, let's talk about rules. So we've talked briefly about rules before. What is a rule? It defines the business requirements for data. So what does this data element, or CDE, need to look like? It determines the legal set of data for one or more elements. It's a strange way of putting it, but essentially you're now saying that there's only one possible set of data that could be correct for a particular element, or more, or one or more. This is important. It's agnostic to the source or the technology of the data. Now, people might disagree with this because we sometimes encounter customers where they're running loads of DQ processes quite happily within SQL or within Python or within their own code. But what we try to do here is to pull apart the technology and the source of the data from the rule itself. Because if you think about it, the rule is just defining what the data should look like, but you're going to discover this same data in multiple places. You might have it transactionally in a database, a SQL database. You might find it in your data warehouse. You might find the same data elsewhere in some S3 bucket or something. But ultimately, wherever you discover that piece of data, that business term, the rule is the same. So with tools such as Ataccama, we pull the rule out and we make it an encapsulated data source agnostic thing, where you pass some data into it and you get a yes or no, it's valid coming out the other end. And finally, I've alluded to it in previous slides, one data element might be valid or not valid, depending on the context. So let's have a look at this. In this example here, I've got this string, 19830228, which you probably, off the top of your head, can spot to be a date. So going from left to right here, I start with what I call detection rules, which is an Ataccama terminology. And this is Ataccama saying, what does certain data look like? And I can suggest that it might be, or probably, is one of these things. So initially, we can see that that looks like a date, even though it's held in a string field. So fine, tag it with, this is probably a date. And then taking it a bit further, if you actually look at the difference between that date and today, if it's within, say, 120-year range with a certain distribution on it, so dropping off down to 0 after you get past 70, you could say this is probably a date of birth. And that, again, that's a detection rule, and we do it statistically. We look at all the data in totality, and if it passes a certain threshold, we can tag with a date of birth flag or a date tag, sorry. And then the user can say yes or no, accept or reject that suggestion, and the product will learn from the types of data it's seeing people tagging or not. Then we go on to DQ validity rules. So now we're definitively saying this is a date of birth, but what's a valid date of birth or not? And you might think, actually, if you look at the detection rule for date of birth and the validity rule for date of birth, they are very, very, very similar. In fact, they're exactly the same. So you've got the same rule in two places here. One is just used for probability. The other is used for validity. Yes, this is valid, or if it's not, why? And that's fine. So far you can stay within your catalog for this type of work. You've got business terms. You know exactly what this business term should look like. And you can say, this is the data quality score for this particular attribute on this particular entity in isolation. But that's not context sensitive. So this is when we go to the last type of rules, business rules or business context specific data quality business rules. This is where a specific piece of data is valid within its context or not. And at this point, we can start looking at one piece of data compared to others. So as an example, we've got this example here. This can't be the date of birth of somebody who has a pension and it's in drawdown, i.e. they're being paid their pension. Why? Because 1983 makes them quite young. They're not young enough to retire yet. So that's still just on the one attribute, but we're now saying whether something is past validation or is past DQ within the context that it's being used. You can also take values and run DQ with them compared to other values. For example, in a payment system, if the payee and the payer are the same person or the same account, you've got a problem. So you're actually saying these are two completely valid accounts, but in context or combination with each other in the context of a payment, the payment is in error. So that's where we get to context-specific DQ, and we go to a different part of our product and create these business rules. Again, still in a technology agnostic manner, and we apply them to the data where we feel it's relevant. So data quality dimensions, a sort of slight tangent really coming into this. You could talk all evening with people who are data specialists about how they feel data quality dimensions should be used. Some people feel that it's really important to tag every rule with the type of rule that it is. Others think of this as a tool for determining which rules to create. Text at the bottom is actually from the UK government, and this is how they see it. It's important to select dimensions that describe your data as being fit for purpose, or as it's intended to be used. The context is important. So I think of it as, here's some tools for me to think about what I might want to consider valid or not when I'm creating DQ rules. Validity, and you'll see multiple versions of dimensions, more than 6 different names for them, depending on where you go. This seems to be the most common, these 6. Validity just says the structure of it looks correct. You know, DDMMYY, whatever, it looks like a date. In this example, telephone number, is it the correct international format? Accuracy says, fine, it's valid, but is it accurate? I.e., that looks like a real phone number, but if I were to pick up my phone and call it, does it ring? It's a real number or not, and that's how we think of accuracy. Completeness, fairly straightforward. Is there a value there or not? Sometimes it gets interesting if you think about certain systems with default dates of 1/1/1900. Is that complete or empty? Sometimes that means it's empty. So just bear that in mind. There are occasionally some oddities with completeness. The difference between null and an empty string is another example. Uniqueness is fairly straightforward. Often we look at uniqueness when it's, unique keys, primary keys, that type of thing. Is this the only one of these things I've got in my entire data set? Or the example here, contact person has only one primary number. Couldn't have two primary numbers. Consistency, this is where you have the same data in multiple places, or you have one piece of data that's dependent on another and it's not correct. So I've got here, you've got a CRM and a billing system, they both contain contact details. Do they match? As an example. Timeliness, this is just basically saying, can we rely on data that's old? And here, the example, again, telephone numbers, are the contact details related to this person up to date? And you'll often log into a website and see, here's the email address or the phone number we have on record for you. Is this still valid? And you say yes, and then you're logged in. That's a result of someone having timeliness checks. How much of my data seems really old? And so those are DQ dimensions. And as I say, I like to think of those as a tool which just helps me determine what rules to create. But some people like to see reports grouped by these categories, and it's completely up to you how you deal with DQ dimensions. Finally, or not quite finally, data quality monitoring. So as we said before, there's source data, you know where it is because you cataloged it. You've got data quality rules because you know what business terms you have and you know what defines those business terms as being valid or not. Furthermore, you've created a bunch of business area specific rules which measure data quality in context. How do you bring it all together? Well, this is the Ataccama terminology, data quality project. You have your list of rules and your list of source data. You pick from both of those lists things you want, and you can get help with this by automated or suggested rule to data mappings, and you create a DQ project, and that DQ project will then go grab the data and run the rules and give you results. The term for results is data quality metric. So you can say an account number needs to be 8 digits, fine, but on this billing system, on the accounts table, there are 1 million accounts and 200,000 of them aren't 8 digits. That's your metric. So you've got 80% DQ validity, but 20% invalidity, and that would be a metric. What you do with those metrics next is up to you. Ataccama has visualizations built into the product, reporting, out-of-the-box reporting. There's also data stories, but you can also send invalid data to spreadsheets or to Power BI or to other products as you wish, or back to source systems. Here's an example DQ dashboard. And if you are going to watch the video of the expressions, which is May Kwok's introduction to Ataccama rules, you'll see this is the example that she's doing in that session. And you have got here a birth date. And you can see at the bottom here, we've got 65% data quality valid, which is good, but you can see all different examples of why certain rows, the other 35%, have failed. A key thing, and it will come up in the rules session, but the way that we like to think about DQ is what we call optimistic rules. So it assumes your data is correct. So it starts off as being valid, and then it goes to try and find reasons why it might not be valid. The reason we do optimistic rules like that is because there's multiple places that it could be invalid. If you just assumed invalidity, then that's just one thing. It's not valid. And then you go and find a reason for it to be valid. You've really only got a binary answer there. Here, we get more information. It's empty, or they're too old to be a date of birth, so on and so forth. So assume validity and then go and find reasons not to be valid. Again, a debatable point, depending on who you speak to. This is a complicated diagram, but we're back to our original simplistic view of problems here. And now you can see a bunch of green arrows coming from source or load or reporting. And what we're saying here is that there's many points in your movement of data, as we call the lineage of your data as it moves through various systems. There are many points where its quality might change. Often when you start out with a DQ project, as a new customer, you'll pick a certain area you know to be either more of a concern or not, or easier to get at the data. Oftentimes people go to a data warehouse because everything's there. But you can run your data quality checks at various points in your movement of your data. But that's all very well and good. You're now monitoring. You've got this thing, DQ monitoring, is directly in the middle here. And that's you actively monitoring your data quality. But what are you going to do with the results? So going off to the right here, I've got slice, dice, and analyze. There are many, many, many ways of doing this, either within Ataccama itself, using data stories or the dashboards, or taking a CSV extract out, or using Power BI. It's a very common approach is to take everything out that failed and put it somewhere which specializes in really deep diving through your errors and analyzing what's going on. I would say the majority of people stay within Ataccama for that, but maybe 30% will pull some data out elsewhere for further analysis. Or you can take data quality issues and load them to issue management software. In Ataccama, we have the data quality issue tracker module. You've also got tasks within the new version 14 that come out where you see issues. You can raise a task and assign it to a person directly in the product. I've put Jira here because the little blue diamond icon there, because we support putting issues into other systems. Now, the green arrow going from DQ monitoring into issue management is interesting because there's business logic that needs to be put in that arrow. So if you have 100 rows on a table and there are 50 errors, you could probably create an issue individually for each one of those 50 rows in error. But what if you've got 10 million rows or 100 or billion rows, as we have in certain customers? You need to think about, how do I want to aggregate that information and what constitutes an issue for me? Often we'll have a roll-up at the entity level saying the customer table has 1 million rows, 800,000 of them are fine, but 200,000 have failed on, I don't know, phone numbers. And that one piece of information becomes an issue. And we can write logic which will check how that's moving over time. Maybe if it breaches a certain threshold in a positive direction, you could automatically close an issue. Or if it breaches a threshold in the negative way, you could create an issue. And there's various things you can do. But it's important to note that when you start to go to active issue management and assigning automatically tasks to people to resolve, you may need to put business logic on that line. Then how do you do remediation? Well, multiple ways. The easiest, or the best way, I should say, not necessarily the easiest, is to implement a DQ firewall and stop the bad data coming in the first place. What you can do is take an Ataccama rule and you can surface that as an API, give that API endpoint to your developers of the source system, and they can integrate that into their data entry piece of their, whatever it is, web form. Or if you know certain things that are going wrong, for example, if a number becomes a string and then goes back to a number again and you lose the leading zeros off the string, which often happens, you could put them back on if you knew this was a specific thing. Put them back on and automatically go and update the source system. It's not a common design pattern, but it has been done. And often happens, this is really for where you have an MDM, well, consolidation mastering, you create a golden ID for something. Like this is the one corporate-wide customer ID for this person or customer. You can send it back to source systems alongside their own IDs, so that they know they've got the golden source customer ID as well. And then finally at the bottom, the little picture of a person manually remediating problems. Let's not discount this, because understanding what's wrong with data requires the human eye very, very often. And taking an extract as a spreadsheet, taking data into some data warehouse and almost manually going through that, your list of problems, and running queries against it is a very, very valuable and probably the most common way that we deal with remediation. You don't always have to go into the source system and type everything in manually. You could create a CSV of corrected data and hand it to the owner of that source system, for example. So that's remediation. And again, so remediation is the thing that's different wherever you go, and you kind of need to actually look at what you want to do at this point and then implement something to achieve that. So finally, the key takeaways. Why are we doing it? Reducing risk. That's the main reason. And risk is financial, but also all those emotional things. Frustration, sleeping well at night, getting your time back so you can see your kids, and improving your confidence in your data and other people's confidence in your data too. What is it? It's not just a tool, it's people and processes as well, and you've got to get the whole thing correct. How? 2 ways. One, you do maturity assessment, measure, improve and repeat, and do the same with proactive DQ. Who does it? Well, this is probably out of scope for this particular session, but you have to decide whether you're going to centralize into a single central DQ team, or federate and democratize and give the responsibility of this to all the individual business units. That's the nirvana and the ultimate end state, but mostly people start central, prove value to different divisions, and then start to socialize the value add, and then people will start to engage with the product. When? Now. Well, why not start right away? And that's it. If you were in the room, you could have won some merchandise. However, here's the pop quiz question. How tall was Liam? He was 6'2", or if you believe the NHS, he's 6.2 centimeters high. And that's it. Thank you so much for listening. Any questions, you can find me on LinkedIn or get in touch via the support desk. And I hope you enjoyed the session.